Every evening, as the sun dips below the horizon, the composition of the open ocean changes. Billions of unseen bodies rise from the deep, flooding the surface layers with a biological mass that rivals the world's largest land ecosystems. We only discovered this movement by accident. This diagram illustrates what naval sonar operators saw during World War II. Their instruments detected what appeared to be a solid ocean floor, hundreds of meters thick. But this false seabed did something impossible. It rose toward the surface every night and sank back down every morning. This phantom seabed consisted of 5 billion metric tons of marine organisms. This biological commute, exceeding the weight of every herd and flock on land, carries life to the surface to feed on microscopic plants in the dark. At dawn, they flee back to the depths to escape predators that hunt by sight. This daily movement is called the diel vertical migration. These creatures are retreating into a realm that makes up 90% of our global ocean. We have mapped the craters of Mars in greater detail than the topography of this lightless underwater expanse. To understand where these billions of tons disappear to, we must leave the sun behind. We are descending into a laboratory where the standard rules of biology no longer apply. Between 200 and 1,000 meters down, we enter the twilight zone. Sunlight here is reduced to a faint blue haze, a mere 1% of what shines at the surface. In this dim arena, survival depends entirely on the manipulation of shadows. Some species have erased their own visibility. These deep-sea jellies possess completely translucent bodies, leaving only delicate, glass-like tentacles drifting in the current. Without pigments to catch the remaining light, they move through the gloom without casting a silhouette. Others generate their own light to hide. A predator looking up from below normally spots a dark shape blocking the faint sunlight. To prevent this, creatures like the firefly squid produce precise chemical light on their bellies, matching the exact brightness and color of the surface water to vanish into the background. Hunters in the twilight zone use the opposite tactic. Certain fish have evolved ultra-black skin. The surface of their bodies is packed with a hyper-dense layer of pigment that absorbs nearly 100% of the light that hits it. A spotlight can shine directly on them, and they remain little more than a void in the water. Teeth and speed offer little advantage in this space. The winners in the twilight zone are the animals that achieve total control over the scarce, fading light. Past 1,000 meters, the last photon of sunlight disappears. We are in the midnight zone. The water temperature hovers near freezing, and the hydrostatic pressure exceeds 100 times the atmospheric pressure at sea level. That weight would shatter a rigid skeleton. Biology bypasses this by discarding bones altogether. Many animals here have soft, gelatinous forms, composed almost entirely of fluid. Because water resists compression, these flimsy-looking bodies withstand forces that would crush a submarine. But the midnight zone presents a secondary problem: isolation. Finding a mate in millions of cubic kilometers of black, freezing water is a near mathematical impossibility. The deep-sea anglerfish forces a grim solution. When a tiny, weak male locates a massive female, he bites into her flesh and fuses his body to hers. His eyes, fins, and internal organs dissolve until he is reduced to a permanent parasitic sac of sperm, nourished by her bloodstream. When the physics of an environment makes standard biological interactions impossible, life negotiates ruthless compromises just to ensure the continuation of a species. At 4,000 meters, we hit the abyssal plain. This is an endless desert of silt, where the primary currency is marine snow. This slowly drifting organic debris, bits of decaying flesh and plankton waste falling from the world above, is the only source of nutrition for thousands of miles. To survive on such sparse rations, life scales up. This giant squid carcass, stretching out past the measuring tape and the researchers standing nearby, is a prime example of deep-sea gigantism. By growing to massive proportions, these invertebrates can store more energy and dominate the few meals that sink to the bottom. Beyond the plains lie the trenches of the Hadal zone, plunging to 11,000 meters. The pressure here is so hostile that our only access is through extreme industrial engineering. To reach these depths, humans relied on vehicles like the Trieste, sealing themselves inside this heavy steel sphere forged by Krupp to keep the ocean from crushing them. Illuminating this rocky, alien terrain, submersibles like Alvin revealed a biological anomaly: hydrothermal vents. In these volcanic fissures, entire ecosystems thrive on chemosynthesis. Instead of relying on falling organic matter, thick clusters of tubeworms and crabs feed on bacteria that consume the superheated, toxic exhaust spewing directly from the Earth's crust. These vents prove that biology does not require a star to flourish. Life can construct a complex, thriving counter-economy fueled by the geology of the planet itself. These deep-sea biological hacks regulate the surface climate. By continuously cycling through the water column, these creatures sequester 2 billion metric tons of carbon away from the atmosphere every year, locking it in the abyss. But the buffer between the surface and the deep is collapsing. Human industrial waste is sinking into the trenches faster than our scientific exploration can map them. When scientists look at the sediment, the findings are stark. Researchers analyzing samples pulled from the very bottom of the Mariana Trench are finding synthetic microplastics already embedded in the tissues of bottom-dwelling crustaceans. The pollution has outpaced the exploration. Now, massive industrial vessels are preparing for deep-sea mining. These operations plan to scrape the abyssal plains for rare metals, threatening to obliterate slow-growing ecosystems that have persisted in the dark for millions of years. The deep ocean is Earth's ultimate laboratory of resilience. Its inhabitants have hacked pressure, dissolved their own visibility, and built life from toxic chemicals. They have survived every physical limit the planet can impose. Now, their survival depends entirely on our restraint.